what we did on Thursday, synthetic division, okay? This is a fourth degree polynomial. So how many solutions? Up to how many solutions could you have? It's a fourth degree polynomial. How many solutions? You're thinking turning points. How many? 4. 4, okay? You've got to think about multiplicities. So if you have a number that repeats, then one of your solutions may show up twice. But you're looking for 4 solutions. What you are going to do here is you are going to start with synthetic division. And then you are going to go and you're going to continue. So this takes a few minutes. I'm going to give you about 3 or 4 minutes to do this. It tells you that 2 and -3 are solutions. 2 and -3 are solutions. We already know that 2 and -3 work. So what are you going to start with synthetic division? What are you going to start with? What number? What number are you going to put in the box? Oh, you're on the right track, but I'm not giving you the factor. The factor would be x minus 2. So the solution is 2. So you're going to put 2 there. Okay? And I'm going to tell you right now, you've got to do synthetic division twice. So the next time that you have to do synthetic division, use the -3. So start with 2 and then go to -3. Synthetic division coming back to you. Okay, I'm going to let you do another synthetic division in just a second. Okay? You've got to be able to do synthetic division. Okay? You've got to be able to do synthetic division. So what I have taken right here, what is this? What's this right here? Okay, but is it a factor? What is it? Solution. Okay, so this right here is a solution. Okay? 2, 7, -4, -27, and -18. What are those? The coefficients. Okay? So I brought a 2 down, and then I did 2 times 2. Okay? The 2 came straight down. I got the other 2 from right here. So 2 times 2 is 4. 7 and 4 is 11. I multiply that times the 2. I got 22. -4 and 22 is 18. 18 times 2 is 36. -27 and 36 is 9. 9 times 2 is 18. Okay? What does this remainder mean right here? What does that remainder mean? It what? What does the remainder of 0 mean? It means it was a solution. It means it works. Okay? It means it works. So, if 2 is my solution, x minus 2 is my factor, and 2, 11, 18, and 9 are coefficients that go with my polynomial. So I have 2x to the third plus 11x squared plus 18x plus 9. Okay? So if I multiplied these two things together, what would I get? Yes, I would get my original. Now, at this point, I always check to see if I can factor. Okay? Because factoring is the way to go. Okay? Can I factor this? Can I factor this? Can I factor this? I cannot factor this. Okay? I could take an x squared out, and I would get 2x plus 11, but here when I took a 2 out, or a 9 out, would I get the same thing? That would be 1. Would I get the same thing? So this can't be factored, and when it can't be factored, what do we have to do? Oh dear, come on guys, you know this. This is what we did on Thursday. If you can't factor, what do we have to do? Well, if it was a quadratic, but is this a quadratic? So you're correct. If it was a quadratic, if it was to the second power, we would have to use the quadratic formula. But this isn't to the second power, it's to the third power. So what do we have to do when we can't factor? No, that has to be a quadratic also. We just did it. What did we just do? Synthetic division, okay? So now we've got to do synthetic division again. Just like on all the homework you practiced over the weekend on polynomials, right? Oh, I'm worried. Okay, so I'm not going to worry about that right now. We're going to worry about something else. So here we go. Okay. I am told what another solution is. What is another solution? Good. So I'm going to put -3 right here. Okay? Now I'm going to bring down my 2, my 11, my 18, and my 9. Okay?
I thought we were supposed to do it with the same numbers.
You do not want to do that. Okay, because so you could, but then you still don't have a smaller polynomial to deal with. if you were doing it with the same numbers that you started with, you're just confirming that that's a solution. And that is okay if it's saying confirm that 2 and -3 are solutions. That would be fine. But when you are trying to find all the factors, you need to keep going with that. Yes?
When we do the first synthetic division, doesn't matter which one we choose?
Nope. Doesn't matter. And you know, if you did -3 first, did you get, when you did the second -3, did you get something that was factorable?
I didn't try.
Oh, okay. You might end up with something that's factorable. So, you know, if you're like, oh, I don't want to do synthetic division again, you can go back and try the -3 and see if it gets something factorable. But you might not. Okay? So, here we go. I bring down my 2. What do I multiply my 2 by? Good. -3. What's 2 times -3? 11, and -6 is? Okay, I'm going to multiply 5 times. Okay, what's -3 times 5? Good, and what do I get? 3 times. Good, and I get -9, and that gives me 0. If I don't get 0 there, what do I have to do? Yeah, if we're dividing. If I'm trying to find solutions and I don't get 0 here, that means that it's not a solution and I've got to do something else. Okay, so what I have now is I have x minus 2 as a factor. I have x plus 3 as a factor. And I have 2x squared plus 5x plus 3. Okay? Okay, I'm not done. I need to keep going to find all my solutions. I've got 2 of my solutions, but I don't have the rest. So I'm going to go to the next screen. I think I'm going to the next screen. Yes? Okay, right here. Is this what you're talking about right here? Yeah. Okay, because if I put x plus 3, if I put x plus 3 equal to 0, what do I get? Good, okay. So x plus 3 is my factor. What's -3? Yes, ma'am, you got it. Okay? So there we go. Okay. Now I'm just going to the next screen and we're going to keep going. Is that okay? Does everybody got what they need? Okay. So what was my highest exponent? From the original problem. 4 was my highest exponent on my original problem. I had x minus 2 and x plus 3. Is that right? And then what was my quadratic or my trinomial?
2x squared plus 5x plus 3.
Good. Okay, now, can I factor 2x squared plus 5x plus 3? Who said no? Okay, and if you didn't think that it could be factored and you end up doing quadratic formula, you will still get the correct answer, okay? It can be factored. This can be factored, okay? What is the product that I am looking for? What's the product? I heard it. 6, okay? 2 times 3 is, okay, and what's my sum? 5, okay? So I need 2 numbers, multiplied together give me 6, and added together give me 5. 3 and 2, okay? So my numbers are 3 and 2. Those are my numbers, okay? So I have 2x squared plus 3x plus 2x plus 3. All I did was I took 5x I took 5x and I turned it into 3x plus 2. That's all I did. Okay? And if you're struggling with factoring, we need to talk yesterday. Okay? If you're struggling with factoring, we need to talk. Okay? Now, I'm going to factor by grouping. I can take an x. I do that every time. I can take an x out of the first two. So I'm left with 2x plus 3. What can I take out of the second two? A 1. Excellent. And so I'm left with 2x plus 3. Okay? So I have x plus 1 and 2x plus 3. Okay? These are my factors that go with the quadratic. The 2x squared plus 5x plus 3. Okay? I can bring down these two factors that I'd already figured out. So I have x minus 2 and x plus 3. Okay? Okay. What this is right here is complete factored form. You will also hear it said that they are linear factors. I have factored all the way to linear factors. Okay? That's something that you will call it. Now, I want the solutions associated with each one. What is the solution associated with x minus 2? Positive 2. What's the solution associated with x plus 3? What's the solution associated with x plus 1? Okay, and for this last one, 2x plus 3 equals what? It equals 0. 2x equals, so what does x equal? Negative 3 over 2. Okay? So, these are my solutions. Okay? They are where graph crosses what? Good. Okay, they're where the graph crosses the x-axis. Now, including multiplicities, have I accounted for? Yes. Okay? So, what we did right there, that's what we're going to focus on Thursday, but we're going to throw in irrational as well as complex solutions. Okay? But that's kind of where we're at. That's where we're going. So before we can go there, I want to talk about complex solutions, or complex numbers is what we're going to talk about. Okay? Is it okay if I move off this screen? Okay, so complex numbers. Complex numbers. So we're going to talk a little bit about what complex numbers are. This is kind of what we're doing today. Okay, so we are going to talk about this imaginary unit I. Okay? This imaginary unit. Sometimes we have been in a situation where our quadratic does not cross the x-axis. Okay? Our quadratic does not cross the x-axis. When that happens, we still have a solution, but our solution is not real. Okay? We still have a solution, but our solution is not real. Okay, so the solution is complex and does not cross x-axis. Okay? So the solution is not real, and that's important right there. It has no real solution. It does still have solutions. So what we're going to focus on is we're going to focus on this imaginary unit, I. And I is the square root of -1. And you need to commit that to memory. And just as important is I squared. So you need to know that I equals the square root of -1 and that I squared is -1. You want to commit that to memory. Now let's talk for a second about where these imaginary numbers fall in the sets of numbers that we deal with. So I want you to think back to before kindergarten. Before kindergarten, where did your numbers start when you first started learning about numbers? Before 0. Where did they start? What? Okay, and where does that start? 1. Okay, so sometimes people call these kindergarten numbers, they're also called natural numbers. Okay, and natural numbers started with the number 1. Okay, typically then, when you went to kindergarten, what number did you learn about? Could you have no cookies and your friend have 3 cookies? So what number? 0 was introduced. Okay, and these are whole numbers. And you hung out with whole numbers for a long time. Okay, you learned to add them, to subtract them, to multiply them, to divide them. And those are whole numbers. Okay? Then, along about 4th grade, you learned about a new type of number, and it typically started with temperature. You learned about it for the first time, likely with temperature. Any idea what that is? Not decimals, negative numbers, okay? So, negative numbers integers do not include fractions and they don't include decimals. Integers are whole numbers in their opposite, okay? So you've got -2, -1, you've got 0, you've got 1, you've got 2, you've got 3. Okay, and they go on forever in both directions, okay? But integers do not yet deal with fractions. Then we introduce fractions, and they are called rational numbers. Now, every single integer, every single whole number, every single natural number is also a rational number because I can make them a fraction. 4 and 4 over 1. 0 over anything. Okay? Rational numbers include repeating decimals. So if I have 0.3 repeating, what fraction is 0.3 repeating?
1/3.
Good. It's 1/3. Okay, so I've got repeating decimals, and I have what we call terminating decimals. That means the decimal ends. Okay, so I have 2 and 34/100. That is a terminating decimal. Okay, so rational numbers include everything that we've talked about so far. Okay? This is where all of our fractions come in. And we spend a ton of time with rational numbers. A ton of time. That's where most of our time is spent in mathematics, is dealing with rational numbers. But whenever you started learning about circles, you were introduced to a number that went on forever. Any ideas what that number is? Pi. Pi Day's coming up. It's on a Saturday, though. That makes me sad. Okay? So I've got pi. pi is an irrational number. Okay, and what that means is it's a non-terminating, non-repeating decimal. Okay, so these are my irrational numbers. Other irrational numbers are square roots that aren't perfect. Okay, so the square root of 2 is an irrational number. Now, the square root of 2 and pi are exact answers. Pi is an exact number. 3.14 is an estimation of pi that we use a lot. But pi is the exact, and 3.14 is the estimate or an approximation. Now you can take the square root of 2 on your calculator and you get a decimal approximation, but it's still an approximation. Square root of 2 is your exact. Okay? Now, sometimes when we are dealing with all this, we get an answer like negative infinity to infinity. Okay? Negative infinity to infinity. That represents all of these rational numbers and all of my irrational numbers. Okay? Sometimes when I'm solving an equation, I'll get 4 equals 4. Sometimes when I'm solving a systems of linear equations, I'll get an answer that's equal to each other, but I eliminate all of the variables. What is that answer called? All real numbers. And that's the key word right there, real. All real numbers. So we have been hanging out until this time in mathematics with all real numbers. And there are properties of real numbers that we have learned, and there are properties of real numbers that we count on. Okay? But outside of this set of real numbers, we have an area right here that has I in it. Okay? And this set of numbers is called imaginary. Okay? Now, some of the properties that we learned about all real numbers apply, and some of them don't. Okay? So we have to be careful that we know which ones don't apply and which ones do apply. So up here on the board, I've got real numbers. When I am multiplying the square root of 5 times the square root of 2, when I am dealing with the set of real numbers, I'm allowed to multiply the 5 and 2 together and get the square root of 10. That is allowed when I am talking about real numbers. It is not allowed when I'm talking about imaginary numbers. Okay? So look up here. This is a good thing to take a picture of or make sure you've got written down. If I have the square root of negative 5 and I am multiplying that times the square root of negative 2, if I followed the properties of real numbers in this situation and I multiplied negative 5 times negative 2 together, what would I get inside my square root sign? What is negative 5 times negative 2? What is it? Negative 5 times negative 2. It's positive 10, okay? And that is not the correct answer here. So anytime that you are dealing with a negative inside your square root, you've got to remove that I first. You've got to pull it out first. And that's what I've done. So then I have I on the square root of 5 times I on the square root of 2. That gives me I squared on the square root of 10, which is ultimately negative square root of 10. And we'll do a couple more problems like that. Okay? Now, let's start talking about this imaginary number I. You don't have to worry too much. I'm just giving you a definition. The definition of a complex number is where we have the A and the I, or we have a real number and an imaginary number. Okay? So we have a real number and imaginary. Okay, so something like that would be -4 plus 3i. Okay, so that is the definition of a complex number. We have a real number and an imaginary number. The first set that we're going to talk about is we're going to talk about addition and subtraction with complex numbers. Okay? And they follow the same rules. They follow the same rules as real numbers when we're adding and subtracting. Okay? So we are going to treat I the same way we treat X. Okay? So once we have pulled this imaginary number out, once we've pulled it out of these square roots, then we treat it like it's a variable until we get I squared. Because what does I squared equal? It equals -1. Okay? So when we're additioning and subtracting, we're going to do this the same way that we've been doing binomials and trinomials with variables. You're doing it the exact same way. You're going to treat I the same way that you treat X. However, if you get to something that says square root of -5, what do you have to do first? Take out the I. Take out the I. Okay? So, here we go. We're going to treat this the same way we would treat any other binomial with a variable. So, I have 4 plus 7i, and then I have 1 minus 6i. I didn't need to distribute anything. 4 and 7i are unlike terms, just like 4 and 7x would be unlike terms. 4 and 7i are unlike. So I am going to do 4 plus 1 because they are like terms. Okay, and then I'm going to do 7i and -6i because they are like terms. Okay? Now, if that I was an X, would I have to have the 1 in front of it? Nope. Is it okay if I have the 1 in front of it? It is. Okay? Here, I've got 1 and 3. Then I've got 2i and -2i. Okay? What is 0 times anything? 0. So then I am just left with 4. Now, in this situation right here, this 1 plus 2i plus 3 minus 2i, in this situation right here, this is complex, but what did my answer end up? Non-complex, and that's called real. Okay? So I started with complex and I ended up with real. Okay? We're going to pay attention to when that happens when I'm multiplying, because that's going to be a key thing. Now, what do you think I've got to do here? What do I have to do here? Distribute. What am I distributing the first time? I am not distributing the 3. I'm just distributing the negative. Now, let's talk about that for a second, because I'm not distributing the 3i. I'm only distributing the negative. If I was distributing the 3i, it would have to be written like this. Okay, so be careful of that. Okay, that's not how it's written. I am only distributing the negative. Okay, so this right here is not what I'm doing. Okay, so I have 3i plus 2, because negative and negative make a positive. Then I have negative and a positive, so then I'm left with 3i. So I've got to give that negative to both. Then I've got to do it again. So I've got negative 2 minus 5i. Okay? So let's do our real numbers first. I have 2 and I have negative 2. So what do I end up with? 0. Okay? Then I have positive 3i, negative 3i, and negative 5i. What do I end up with? Negative 5i. Okay? So my final answer here is negative 5i. Now in this situation, I started with a complex, which means both, and I ended with a pure imaginary, or just imaginary, because my real part of it disappeared. That's not as helpful as going the other direction, but it is possible. Okay? So now we are back to 3 plus 2i plus 4 minus I. So I've got 3 plus 2i plus 4 minus I. What do I have to do with this negative? Okay, so I have minus 7 minus I. Okay? 3, 4, and negative 7. What do I get? 3 plus 4 plus negative 7. Good. Then I get 2i minus I and minus I. Also 0. So my final answer to this is 0. Okay. Now we're going to move into multiplication. So, before we can apply the rules of multiplication, we have got to understand when the properties of real numbers don't apply. And we just talked about it up there. Okay? You must address a negative inside the square root first. Okay? Before you do anything else, you must address any negative that's inside the square root. Okay? You have to do that. If you don't, then you can't follow the properties of real numbers. So if I've got 3 plus the square root of negative 2, what do I have to do? What do I pull out? I pull an I out, and then what's left? Square root of 2. Then if I needed to multiply that, add that to another irrational, anything like that, you've got to address the imaginary before you do anything else. So if you've got a negative inside that square root, you've got to deal with it because it doesn't follow the same properties. Now, if I've got the square root of negative 9, that's the same thing as the square root of negative 9, or the square root of negative times the square root of 9. So I'm going to take an I out, but can I also take the square root of 9? Yep. Okay. Now, This is where my students sometimes get confused. Okay, the square root of negative 32. I've got to address that negative, okay? So I have negative 1 times 32, and so that is I on the square root of 32, okay? But 32 can be simplified. What is the perfect square factor inside 32? What times what gives me 32? 8 times 4 gives me 32, and 4 is a perfect square. There's actually a bigger one than 4, though. 16. Okay? So 32 is the same thing as 16 times 2, and we have to simplify that. Okay? What's the square root of 16? 4. So this actually simplifies to 4i on the square root of 2. 4i on the square root of 2. Now, some students write it 4 on the square root of 2i. Okay? So either one of these is okay. But this is not okay. Whoops, it's not 4 on the square. No, it is 4 on the square root of 2. Okay. What's the difference there? Good. The I is inside. Okay, you cannot have the I inside. That's why I like to write it 4i on the square root of 2. You'll always see me writing it like that. 4i on the square root of 2. But you can write it 4 on the square root of 2 times I. But you better make sure that I is not inside the square root. So that is not okay. Okay? Now, we can apply the rules. Oh, whoops, I went too far. We can use our properties of multiplication. Once we've pulled that I out, we can deal with the properties of multiplication. Okay? So, what am I going to distribute? I'm going to distribute the 4. Okay? 4 times negative 2 is negative 8. 4 times 3i is 12i. Okay? I just distributed. What do you think I'm going to need to do down here? I'm going to FOIL. Okay? So I'm going to FOIL right here. 2 times 4 is 8. 2 times 3i is 6i. Negative I times 4 is negative 4i. Negative I times positive 3 is negative 3i squared. Okay? Lots and lots of students will do 8 plus 2i, because they combine those like terms, and then they'll leave this as minus 3i squared. Then they will hit Ask My Instructor, and they will say, Alicia, I have done this 10 times, and I don't understand why this is wrong. What do we know about I squared? It's negative 1. So I have 8 plus 2i minus 3 times negative 1. Okay, and when I do that, I end up with some more like terms. So what's my final answer here? Okay, and just to keep it in the format, your real comes first. It's 11 plus 2i. Okay, so don't stop here. Okay, you got to keep going. Keep going. And I typically have a lot of students that get stuck on that right there. Okay? Okay. I want you to FOIL this one. I want you to FOIL this one for me.
My pen doesn't work, so mine should be able to do it like that.
Okay. So we have 3 times 3, which is 9. 3 times negative 2i is negative 6i. 2i times 3 is 6i. 2i times negative 2i is negative 4i squared. Now we got all sorts of things going on in here. Okay, what happens in the middle? They cancel. Okay, so then I'm left with 9 minus 4i squared. Okay. What is I squared? Okay. So what's my answer here? 13. Now, this is important because what kind of number is this?
I don't know where you're going.
I just highlighted it. What kind of number is this? Complex. And what kind of number is this? Okay. So we have gone from complex to what? Real. And this is important. Okay? What 3 plus 2i and 3 minus 2i are called are conjugates. Okay? What do you notice about them? What do you notice about those? Okay, they're the same, but what's flipped? The signs. Yeah, one of them's plus and one of them's negative. Okay? So this is the property of difference of perfect squares. Difference of perfect squares. Okay, so when I do the difference of perfect squares, what cancels? Middle terms. Okay, and that's the imaginary part, because once I have I squared, I have negative 1, and negative 1's not imaginary. Okay, so these are conjugates of each other, and they're going to be very, very important in just a second. Now, difference of squares is a plus b times a minus b. Okay, and we use difference of squares in our set of real numbers. But the conjugate part, that's important for when we start doing rationalizing the denominator. Okay? Okay, 3 plus 2i. 3 plus 2i. What do we have to do? Good. So I've got to separate it to 3 plus 2i times what? And we are going to FOIL. Okay? 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is 6i. 2i times 2i is plus 4i squared. Our middle terms do not cancel. We have to add those together. What's I squared? Negative 1. So don't stop. You've got to deal with that I squared. Okay? So then I'm left with 9 plus 12I minus 4 and I'm left with 5 plus 12I. Okay. So the next two slides are a little busy. But what we want to do, I want you to remind you why this works. So I have 3 plus 2I and 3 minus 2I. And when I finished with that, what was my answer when I finished with that? What was my answer when I multiplied 3 plus 2I times 3 minus 2I? 13. Okay? So I started complex, and then my answer was real. Okay? So those are called complex conjugates. Okay? You're not going to be drilled on what that means or anything like that. I just want you to know that it works. This is why we have to use it. What I want you to focus on is the denominator. Okay? C plus DI. We cannot have an I in the denominator of a fraction for that to be simplified. We have to eliminate imaginary numbers in the denominator. Okay? We have to eliminate those. So here's my denominator right here. C plus DI and C minus DI are conjugates of each other. When I multiply by its conjugate, I am going to eliminate the imaginary part. Now, but the trick is I've got to multiply the top and the bottom by the same thing. When I multiply the top and the bottom by the same thing, what have I multiplied by? When I multiply the top and the bottom by the same thing, what have I multiplied by? 1. Okay, so I multiply by 1 here. Okay, now this is all the definition stuff. I want to show you what that means. So this is all doing. So here I have 2 plus 3I, and I want over 4 minus 2I. And I need to simplify this because I'm not allowed to have I in the denominator. I have to get rid of that 2I. So what I do is I multiply 4 minus 2I times 4 plus 2I. And if I do it to the denominator, I've also got to do it to the numerator. I get all sorts of things right there. Okay? Sometimes I get negative 4 plus 2I. And then sometimes I get negative 4 minus 2I. Okay? But the only thing you're changing is that to a plus. They've got to be the opposite of each other. They've got to, when you multiply them together, those middle terms are going to cancel out. Now, I need to multiply my numerators together. So I've got to multiply 2 plus 3I times 4 plus 2I. I've got to multiply my numerators together. I'm not going to eliminate my imaginary number in the numerator. It's okay to still have an imaginary number in the numerator, but I still have to multiply. 2 times 4 is 8. 2 times 2I is 4I. 3I times 4 is 12I. 3I times 2I is 6I squared. Okay? So then I have 8 plus 16I plus 6 times what? Negative 1. Okay? So 8 plus 16I minus 6. What do I end up with? 2. 2 plus 16i. And this is my numerator. And in the numerator, it's okay to have I. It's okay to have I in my numerator. Okay? So I have 2 plus 16i. Now, I need to multiply my denominators together. Okay, so here are my denominators. 4 minus 2i times 4 plus 2i. 4 times 4 is 16. 4 times positive 2i is 8i. Negative 2i times 4 is negative 8i. Negative 2i times 2i is negative 4i squared. By design, my middle terms cancel. I'm left with 16 minus 4. What's I squared? Okay, so then I have 16 plus 4, and what is 16 plus 4? 20. That is my denominator. And did I eliminate what I wanted to? I'm going to run out of room. That's my denominator. That was fabulous. Okay, so my denominator is 20. Now, this can be simplified. This can be simplified, and the best way for you not to make a mistake with this is to separate it into 2 fractions. So I'm going to say 2 over 20 plus 16 over 20i. What is 2 over 20 simplify to? Okay. What is 16 over 20 simplify to? 8 over 10, which is? Okay. WebAssign is going to want it in that format. WebAssign is going to want it in 1 over 10 plus 4/5 I. Okay? That is the format that WebAssign is going to want it in. Okay. Now, the whole reason that we're talking about complex imaginary numbers is so that we can have solutions that do not cross the x-axis. Okay? That's why we're talking about it. We can have a solution that's a quadratic that doesn't cross the x-axis, and we can have a solution of any polynomial that doesn't cross the x-axis. Okay? That can happen. You can write a number such as the square root of -3 and enter its standard form by factoring out the I. So we know that. Okay? Now, what this is telling you is that when the square root is given, okay? When square root sign is given, you do not add a plus or minus. Okay? So when the problem looks like the square root of -3, you don't add a plus or minus. When the problem has x squared, okay? Do you see the difference? When the square root is part of the original problem, you do not add the plus or minus. When you are the one taking the square root, that's when you add the plus or minus. So x squared equals -3 is the square root of x squared equals plus or minus the square root of -3. Okay? So, when I start with x squared, I have to add the plus or minus. When I start with just the square root, I don't have to. That's what this slide is saying right here. Now, is so we can have complex solutions to our that we do this quadratics. Okay? Now, we can't factor this. 3x squared minus 2x plus 5, we can't factor. Okay? And if I were to graph this, and I'm going to show you what the graph looks like super quick. That's what the graph looks like. Does it cross the x-axis? No, it doesn't cross the x-axis. That means it's going to have a complex solutions. Okay, and that's what we're going to look at right now. We are going to use the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, where do I get my a, b, and c from? The equation, and they are the coefficients. Okay? So in this situation, my a value is 3, my b value is negative 2, and my c value is the constant. Okay, and you guys have been doing the quadratic formula for a while. Okay? So I have negative 2 plus or minus the square root of b squared. Put that parenthesis there. When you don't put that parenthesis there, students make mistakes. Whoops. Okay, that's just minus. I put plus or minus. Negative b squared minus 4ac. Okay, and that's all over 2a. Okay? Students typically do okay plugging it all in. Okay? So I have negative 2. What's negative 2? Positive 2. Plus or minus. Sometimes we have issues here. Okay? Sometimes we've got issues right here. So you got to be careful there. Okay? Negative 2 squared is positive 4. Be careful if you put that in your calculator. You've got to have that negative around parentheses around it. Then I've got negative 4 times 3 times 5. What's negative 4 times 3 times 5? Okay, and that's all over 6. Okay, 4 minus 60 is negative 56. Don't stop. You're not done. Okay? Students typically do okay till this point, and then they don't know what else to do. Okay? It's just cleanup now. We've done the hard stuff, but sometimes the cleanup gets us in trouble. Okay? So let's do some cleaning up. Okay. 2 plus or minus the square root of negative 56. The first thing we know is we got to take that negative 1 out. Okay, but 56 can be broken down into a perfect square factor. What two numbers together multiply to give us 56, even if it's not perfect? What two numbers do? 7 and 8. 7 times 8 is 56. What factor is within 8 that is perfect? 4. So 7 times 8 equals 56. 4 times what equals 56? 14. Okay? So 56 breaks down to 4 times 14. Okay? So I've got 2 plus or minus 2i. Okay? I got my 2 from this. Square root of 4 is 2. I got my I from this. Do you see that? And what's left? 14. Now, just like with our imaginary ones, I said go ahead and break it up into 2 fractions. You're going to be better off if you break this one up in 2 fractions. So I'm going to have 2 over 6 plus or minus 2i on the square root of 14 over 6. What does 2 6 simplify to? Okay. What does 2 over 6 simplify to? The next one. So I'm looking at 2 and the 6. What does that simplify to? Okay, and then the I and the square root of 14 stay there. Okay? So my final answer to this, I'm going to put it right here in the middle. Okay? 1 over 3 plus or minus I on the square root of 14 over 3. Okay? Now, you could put a 1 in front of it if you wanted to. There's no problem with that. Okay. This right here is why we've kind of done a lot of the different things we've done this chapter. Being able to find complex, irrational, and real solutions to our polynomials is what we're doing on Thursday. So it all comes together on Thursday. Now, one of those things that's just fun for math geeks, you may or may not think it's fun, okay? So let's think about this. If I have negative 1 to the first power, what do I have? Negative 1 to the first power. Negative 1. What's negative 1 squared? Good. Negative 1 to the third power. To the fourth power? Fifth power. Good. So if I gave you negative 1 to the 2,753rd power, why? Why is it negative 1? Because it's an odd exponent. Okay? We cycle through this. 1, negative 1, 1, negative 1, 1, negative 1, based on whether or not my exponent is odd or even. Now, I want to talk about what happens with I when we cycle through. So I is the square root of negative 1, and we call that I. What do we know about I squared? What is I squared? I squared is negative 1. Now, watch closely. I to the third is I squared times I. Do you agree with that? Is I squared times I the same thing as I to the third? Yes. So that is negative 1 times I. So I to the third is always negative I. Now, I to the fourth is I squared times I squared. What's I squared? Negative 1 times negative 1, and that gives me, what's negative 1 times 1? Positive 1. So I cycle through these also. I go I, negative 1, negative I, positive 1. I just cycle through them. But instead of cycling through every other, how many am I cycling through? How many do I have? 4. So if I asked you, what is I to the 39th power? What's a multiple of 4 pretty close to 39? 40 is too high. What's right under 40? 36. So I have I to the 36th. That's a multiple of 4. So what does that factor out to be? What does that become? I to any multiple of 4 power is what? 1. How many do I have left over? 3. And what is that? Negative I. Okay? Now that's kind of a fun little math thing. Okay? That's a fun little math thing that we just want to be sure we got. Okay? Okay. Again, we've already looked at this. Quiz next Tuesday. Test Thursday the 12th. I would strongly encourage you to get a chunk of that homework done. I hope you've done a lot of it already. You really should be through the first two. You really should be done with quadratics and polynomials. Okay? Have a good day.